Both Pfizer and Moderna admit that their injectable lipid nanoparticles have toxicity problems. Now, the reason is twofold. First, because although it's made of normal body fats, cholesterol and disteryl phosphatidylcholine, abbreviated DSPC, they also use polyethylene glycol, abbreviated PEG or PEG, to keep the lipid nanoparticles from sticking together, to stabilize it, and also to control the size of the lipid nanoparticle, which is very curiously the same size as the SARS-CoV-2 virus, about 100 nanometers in diameter. So this polyethylene glycol is toxic and can create an anaphylactic reaction in some people. So if you don't get a bad reaction, the lipid nanoparticles will merge with tissue cell membranes all over your body because the cell membranes are made of the same stuff. No, these lipid nanoparticles don't stay at the injection site. They go everywhere. Something they knew about ahead of time and lied to you about. Inside the larger lipid nanoparticle are smaller lipid nanoparticles that contain the messenger RNA. Now, these smaller lipid nanoparticles are cationic, positively charged, and they will automatically surround and encapsulate the negatively charged messenger RNA. So they self-assemble into mRNA-containing particles. Not robots, not microcircuits, as some believe. Well, guess what? These cationic lipids are toxic too, and they have names. Pfizer used ALC0315, and Moderna used SM102. Now, after these smaller lipid nanoparticles get dumped into the cell, if the pH of the cell is right, these smaller lipid nanoparticles open up and allow the messenger RNA to escape. The problem is the toxic cationic lipids can build up in certain tissues. Research has proven that the lipid nanoparticles can accumulate in the liver, in the spleen, and in the lymph nodes, as shown in this mouse. And yeah, they knew that ahead of time too. The cationic lipids will cause oxidative stress and inflammation. Long-term effects on human health are still being studied and collected amongst the billions of people who got injected. Friends, it's February 2025. We're only 4 years into this. Long-term studies take 10 to 15 years. So, to overcome these toxic problems, scientists are now experimenting with a new delivery system called a proteolipid vehicle, abbreviated PLV, that is less toxic and supposedly safer. They call it a proteolipid because they mixed in proteins with the lipids to make it act more like a virus. The proteins they use are fusion-associated small transmembrane proteins, abbreviated FAST, and they get these from fusogenic orthoreoviruses. Yes, fusogenic orthoreoviruses are found in nature. Here's some electron images. They are a subgroup of reoviruses that naturally occur and are known for their ability to induce cell-to-cell fusion through the expression of fusion-associated small transmembrane proteins. These FAST proteins do not require a specific receptor site to merge with cells, and that's why they picked it, because they want it to go everywhere and merge with any cells, just like the lipid nanoparticles did. I'm fully aware that some of you do not believe that viruses exist in nature. Consider the definition of a virus. It's a non-living particle with a shell of proteins, and sometimes proteins and fats, with genetic material inside of it, either RNA or DNA. And that's exactly what lipid nanoparticles and proteolipid vehicles are. And they spread by injection. and they create an immune response that can be symptomatic. Let that swirl around in your head for a while. So back to the toxicity problem. The PLV is still going to be toxic on the outside because they still use polyethylene glycol to stabilize them and to control their size. But they're not toxic on the inside because they don't use cationic lipids to encapsulate the mRNA on the inside. They just put pure mRNA in there through a special process called microfluidic mixing. And here you can see the mRNA entering the cell directly without being involved in a secondary toxic lipid nanoparticle. So they are less toxic, but they're still dangerous. And to comprehend why they are dangerous, you need to understand the way your immune system deals with the cells that are making foreign proteins while they are being made and before they even get released. Our cells are making proteins all the time. That's what they do. And they always do it with a mRNA template. The mRNA is transcribed from DNA inside of the nucleus. It exits the nucleus and hooks up with ribosomes in the cytoplasm to link amino acids together to make the protein. But your immune cells are constantly monitoring this process. There are many types of immune cells involved in this monitoring process, but there are two specific types of immune cells that have the authority to kill cells that are making foreign proteins before they get released. These are the natural killer cell, or the NK cell, and the cytotoxic T cell, sometimes called the killer T cell. Now, the natural killer cell can detect viral replication, but not protein production from injected mRNA. The mighty cytotoxic T cell does that. And here's how that works. Cytotoxic T cells have receptors on them that will attach to parts of the proteins that are being made and displayed on MHC type 1 sites on the surfaces of the cells that are making the proteins. If the parts of proteins displayed are foreign or non-self proteins, the cytotoxic T cell will send an apoptotic signal to the cell that is making it. Through actions on its own mitochondria, that cell will kill itself by forming little vesicles called blebs. The cell falls apart, and the blebs are eliminated by macrophages that take them in by phagocytosis, and nothing foreign ever gets into your blood or your lymph. Now, normally this cellular destruction and death is no big deal because it happens at the epithelial barrier where viral or bacterial invasions naturally occur. As the non-self proteins are being made, cytotoxic T cells will take them out gently, cleanly, in a non-inflammatory way. Now, due to the abundance of stem cells and progenitor cells, these epithelial cells get replaced with healthy cells very quickly, sometimes in less than 3 days. And this is by design of our Creator, so that the epithelial barrier remains functional. Sometimes the affected person doesn't even know this happened. But when you start injecting the message to make foreign proteins inside the body, it is a big deal. The injected proteolipid vehicles will merge with any organ tissue cells. And as foreign proteins are being made, cytotoxic T cells will take those organ tissue cells out. Due to limited stem cell pools and very complex tissue architecture, not simple like your epithelial layer is, the replacement of these cells can take weeks to months. And if enough tissue loss occurs, you will end up with organ dysfunction, fibrosis, or chronic inflammation because pro-inflammatory cytokines will start getting secreted to try to repair the damage. And there's no way to know how much tissue loss will happen, nor where it will happen, because you don't know what cells are going to be affected. Are you paying attention? All of this is happening before the protein even gets made. The injected proteolipid vehicles will also merge with your endothelial cells that line your blood vessels of all sizes, big and small, including the lining of the heart. The turnover time for cytotoxic T cell damage here is days to weeks. Disrupted endothelial function can lead to vascular disease, atherosclerosis, hypertension, microclots, microhemorrhages, heart attacks, strokes, and myocarditis. And for what? All because you want to make a foreign protein? Why would you do that to yourself? It doesn't matter what the foreign protein is and whether or not it is a toxic protein. In the process of doing this, cytotoxic T cells will destroy cells that are making those proteins. But they're not going to be able to kill all of them. So some foreign proteins do get made, that's for sure. Then you'll get antibodies made against those foreign proteins, which is the goal of any shot called a vaccine. But it can take up to 2 weeks for antibodies to get made. So what happens to those proteins in the meantime? They're biologically active, and they will attach to various cellular receptors. And now we're on a whole new level of tissue destruction. Cytotoxic T cells are no longer involved because they're only looking at MHC type 1 sites. So now you've pissed off your immune system and activated macrophages and neutrophils that are going to kill those cells through inflammatory pathways, whether or not that protein is toxic. If the protein is toxic, it can disrupt cellular membranes and cause tissue damage all by itself without the immune system even being involved. And that's what people are focused on right now, toxic protein production. But that's at the end of the line. The real hidden danger is what happens to you before the proteins even get made. Can you see how dangerous this is? But why do people keep doing it? To get antibody production that cannot prevent you from becoming infected anyway. Nor will they prevent severe disease symptoms because they can prime you for antibody-dependent enhancement that makes the symptoms worse. As always, thanks for watching. Thanks for staying smart.